Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning, everyone. Today we are going to explore ecosystem restoration with a focus on the role of keystone species and how targeted interventions can generate cascading effects across trophic levels and physical environments. Restoration ecology is not simply planting trees or removing an invasive species. It is about restoring processes that sustain biodiversity and ecosystem services. Processes include disturbance regimes such as fire or flooding, nutrient cycling and species, interactions like predation and pollination. A key concept I want you to keep in mind is resilience. The resilience of an ecosystem is its capacity to absorb disturbances while maintaining function. Resilience depends on diversity, functional redundancy, and the presence of species that have disproportionate influence on the system. This leads us to keystone species. A keystone species is one whose effects on its community are greater than would be expected based on its abundance. For example, sea otters and kelp forest ecosystems consume sea urchins. Sea urchins graze on kelp. Without otters, urchin populations explode and kelp forests collapse. That collapse reduces habitat for many fish and invertebrates and alters carbon sequestration. The classic example is Yellowstone, where wolf reintroduction produced a trophic cascade that changed vegetation and even river channels. When wolves were removed, elk browsing intensified, willow and aspen declined. Without that riparian vegetation, stream banks eroded. After wolves returned, elk numbers and behavior changed, allowing woody plants to recover. This in turn stabilized banks and altered sediment deposition patterns. We should be careful not to oversimplify. Every system is different, and the outcomes of reintroductions can vary depending on context. For instance, a predator reintroduction in a fragmented landscape may not yield the same cascade if prey populations are depressed, or if human disturbance prevents natural behavior. I want to discuss 3 restoration strategies with examples. First, active habitat restoration involves planting native species, controlling invasives, and reestablishing hydrology. Coastal wetland restoration in the Mississippi Delta has used controlled breaching to reintroduce sediment to dying marshes. Second, rewilding references the restoration of natural processes, often via species reintroductions or protection of large mammals. The Iberian lynx reintroduction has improved small mammal community dynamics and helped restore shrub steppe function in parts of Spain. Third, assisted migration is a controversial but increasingly discussed approach where species are translocated to areas predicted to be suitable under future climates. For example, several plant species at high elevations are being trialed at slightly higher latitudes to preserve genetic lineages threatened by warming. Beyond biological approaches, we must include socioeconomic tools. Economic valuation of ecosystem services can influence policy. Coastal wetlands provide storm protection, water filtration, and carbon storage. Putting a monetary value on these services can be persuasive for decision makers faced with trade-offs between development and conservation. Monitoring and adaptive management are essential because restoration is experimental. The use of control plots, long-term demographic studies, and pre- and post-restoration surveys allows managers to test hypotheses and refine actions over time. I will close with a caveat and a hopeful note. The caveat is that restoration cannot always recreate original states once thresholds are crossed. For example, prolonged soil salinization or irreversible species extinctions limit recovery. The hopeful note is that targeted interventions that restore critical processes can deliver outsized benefits for biodiversity and human well-being. As you prepare for the paper, consider how you would design a restoration project for a degraded urban wetland. Which keystone interactions would you prioritize, and how would you measure success?
Listen again to part of the lecture. Then answer the question.
The classic example is Yellowstone, where wolf reintroduction produced a trophic cascade that changed vegetation and even river channels.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.